Hello, my name is Janar, and this is CSE310 final project presentation. This assignment was given as a final group project for CSE310, Computer Networks course at SUNY Korea. And its main purpose was to give students an opportunity to gain hands-on experience with networks and solidify their theoretical knowledge about computer networks. So each group of students were supplied with an SDR and were instructed to solve these tasks. They were instructed to make an RF jammer, an FM radio receiver, and a DMB receiver / transmitter. So let's talk about the technical setup first. For the operating system, I was using Windows 10. Speaking of GNU Radio, I was using the version 3.7.11.1, version 1.3. Speaking of SDR, I was using USRP B210, and also I was using this driver that was made specifically for USRP devices and other applications. I was using USRP Windows drivers and NetSplit application. So the first one is RF Jammer. The objective was to jam Wi-Fi, LTE, and 3G networks around me. To avoid causing trouble to other people, since RF jamming is technically saying it's illegal, I've configured my own router to transmit signals at 2.412 GHz. That's the first channel on my Wi-Fi, and I set up the bandwidth to be 20 MHz. Okay, after configuring my router, I used the NetSplit app to check that I've actually configured my Wi-Fi to the specs specified before. So speaking of GNU Radio flow graph, here the structure is pretty easy. I have a noise source. I increase the amplitude of that noise source by 30, and then send that noise signal to USRP sync. I've also increased the gain value to 90, that's the max value for my USRP B210, and the center frequency is configured to the frequency of my Wi-Fi. So now is the demo. So as you can see, my Wi-Fi is on channel 1 and its name is LAN Solo, and I'm connected to that Wi-Fi now. So let's load the flow graph into USRP B210. So it's loading, and I'm still connected to the Wi-Fi. So the jammer is up and running. You can see the noise, and if we go to my networks, you can see that my network is gone, and the app says that there's no signal. The next thing was 3G and LTE jamming. To avoid causing trouble again, I was jamming my own iPhone's internet connection on both 3G and 4G LTE connection. I was using KT. So first things first, I was using field test mode on my phone by dialing these numbers, and it would give me its UARFCN number that can be used to derive downlink and uplink frequency of my connection. So getting the frequencies, I've got some help from a website called cellmapper.net, and I've converted these numbers into uplink and downlink frequency for my 3G and LTE networks. My phone was using 2167.2 MHz and 954.3 MHz respectively. So now the jamming. The jamming technique works pretty much the same as it did with Wi-Fi jamming. So I specify the frequency and I jam it with the noise. The second one is FM radio receiver. Here the objective was to receive an FM signal and play it on my computer. So setting the GNU Radio. So here I specify the center frequency, which is 106.1 megahertz, and then I pass the signal to low pass filter, which basically gets rid of all the high frequencies, and then it gives it to WBFM receive module, and then it gives the signal to rational resampler, which basically decreases the sampling rate of these signals, and then it gives all the signals to AutoSync to play it. This is the WX GUI, and as you can see, we are connected to KBS2, and here are some other stations, EBS, KBS3, Seoul FEBC. So I will show you the demo. So the firmware is loading into the device, and now we're connected to 104.5 megahertz, an FM station from Seoul. As you can see, an FM receiver is working. So now the DMB receiver. So with the DMB receiver, there are not many open source projects available, but I managed to find this repository that was made in 6 years ago, which is 2014. But guess what? I realized that the exact same code is now the part of GNU Radio itself. So they had some examples. So I just had to get the repo and check out to version 3.7.11, which I did. And the GNU Radio flow graph looked like this. So it would get the source and transcode everything and send it to a file sync that would save it to .ts file extension file. But unfortunately, I had file permission access problems, and I could not find any solution to this problem. However, as you can see, my device was actually capturing the signal. The only problem was writing it into my disk. Now the DMB transmitter. I found another example in GNU Radio's open source files, and here it basically takes the file source and transcodes it back to bytes and gives it to a UHD USRP sync, which transmits everything, and then we're live. This was my Qt GUI that was showing the signals that are being transmitted, and here's the demo. So first thing first, I will set up a local server on my device and open up a port 79355, and then I will send the video in GNU Radio to an UDP sync on that server, and let's run it. The flow graph is loading into the device. Yep, the video has started transmitting. So now we have to go to VLC player and connect to that server where the file and sync is sending the video to check that the video is streaming. Yep, the video is streaming. It's a trailer from Adventure Time that I've converted.
Hey, is that new?
Yep, that's it.
Like this?
And thanks. If you have any questions, you can leave a comment below. And this was the video for CSE310 final project presentation.